Okay, guys. Let's start filling in a little bit of info about our graphs here. All right, guys, up here. Okay, guys, exponential. We're going to graph y equals 2 to the x first. If I plug a -1 in for the x there, what do I get? I do not get -2. That x is an exponent. It's not 2 times -1. It's 2 to the -1. What does that mean? Yes. Negative exponent means move it to the denominator. All right. What if I plug in 0? What's 2 to the 0? 1. Thank you, Ben. Anything to the 0 power is 1. Well, not 0 to the 0, but everything else. Yeah. All right. I bet we can do the next one. What is 2 to the first power? 2. All right. What about 2 squared? 4 and 2 cubed. Okay, let's plot these points. So -1, I'm going to plot 1/2. 0, 1. 1, 2. 2, 4, and then 3, 8, which is all the way at the top. Now, when you normally graph exponentials for me, you do not have to graph this many points, but this is making sure you understand the shape and how all of this works. Okay? All right, the way this looks, we actually have a horizontal asymptote for exponentials, and for this parent graph, it's always at y equals 0. So you can think about that horizontal asymptote. So your graph is going to follow that asymptote on the left. That is what an exponential graph looks like. Is that familiar? It's somewhere in your brains. Yeah, you remember graphing this? Okay, I'm going to switch to a different color and do the log graph on the same xy axis here. So guys, log graphs, they are inverses of your exponential. What do we remember about inverses? Kind of. We switch something. Yes, so look at our table. Do you see how over there the x values were filled in for us? The -1, 0, 1, 2, 3. And now those are the y values that I have. So what do you think is going to go here? Yeah, the 1/2, the 1, the 2, 4, 8. So we're going to write those in. Bless you. And we'll plot those. So over 1/2, down 1, 1, 0, 2, 1, 4, 2, 8, 3. Okay, and the exponential graph had a horizontal asymptote. What kind of asymptote do you think this is going to have? Vertical, yes. So your log graphs have a vertical asymptote. Instead of y equals 0, it's x equals 0. And so your graph follows that asymptote. Okay, can you guys see it, how they're inverses, like they're reflections across that line, y equals x? Okay. We, again, are not going to use that many points when we graph. We're just going to use a couple of points. So what I have written for you next, for your parent function of an exponential, you always have the ordered pair 0, 1, and 1b. B is your base, okay? So whatever the base of your exponential is, you know those 2 points. I'm only going to ask you for 2 points. So you'll plot those, and then any sort of transformations that are happening, you'll have to do to those 2 points, and then you can draw your final graph. Only the b is the base? Yeah, does that make sense? Okay, so yeah, 0, 1 is 1 point, and then 1 comma whatever the base is. Okay, it'll make sense when we actually do one. Exponentials, again, your domain. Look back up here at the red graph. What would you tell me about the domain of that red graph? Negative infinity to infinity, actually. It doesn't stop at 0, right? Like there, it doesn't stop here. It keeps going over here. Yeah, okay. So domain is negative infinity to infinity when you're dealing with exponentials. What would you say about the range of that red graph? Yeah, 0 to infinity. And guys, the 0 is not included. It approaches that asymptote, but it does not get there. So 0 to infinity. All right, your x-intercept. Look at the red graph. Does it cross the x-axis? No, so none. There's not an x-intercept. What about your y-intercept, guys? Okay, and how do we write that? Okay, good save. Okay, and your asymptote, we said with exponential, you always have a horizontal asymptote, and it is at y equals 0. So that's the information you're starting with every time you begin an exponential graph. And then if there's a shift, a stretch, a reflection, those sort of things, you'll have to deal with them.
Is it possible for that to have a vertical asymptote?
Nope. It would no longer be an exponential function. So. Okay, so let's think about our log function. We should be able to fill in all this information without even looking at the graph again. We know the x and y have been switched. So what does that mean about the domain and range? Yeah, exactly. The range is now the negative infinity to infinity, and the domain is 0 to infinity. X-intercept is 1, 0. And what about the y-intercept? None. Good. And instead of a horizontal asymptote, we have a vertical asymptote at x equals 0. Okay. All right. So far, so good? I can sense how they're related. Okay. This looks kind of scary, like there's a lot of information. But this is just all the different types of transformations that can happen. Okay? A, that coefficient in front tells us about if we're stretching our graph, if we're flipping it over something, or if we're compressing it. So if A is negative, what does that mean? Like if you have a negative leading coefficient. Flip it over which axis? X-axis. Yeah, you're flipping the y values change sign. So if A is negative, you're going to reflect over x-axis. Okay, if that coefficient is bigger than 1, like if you have a 2 or a 3 out in front, what is that doing to the graph? Stretch vertically, though. It's the y values. So vertical stretch. Okay, then the third part, if A is between 0 and 1. So if A is like a fraction, like 1/2, it's still vertical, but yeah, it's a compression. So you're like smooshing it this way, okay? So vertical compression. I'm abbreviating because I'm running out of room. The A value, what you're doing with that, you can make yourself a little note. That's what you're going to multiply the Y values by. So you can do like the flip and the stretch all at once if you want to. Okay. So let's say there was a -2 out in front. You could do it in 2 steps. You could be like, okay, I'm going to flip everything, and now I'm going to stretch by 2. Or you could just go, oh, multiply by -2. That flips and stretches all together. That makes sense. We'll do some so you'll see it. Okay. The C, do you guys see how the C is like in with the X? It's either up in the exponent on the exponential or inside the log part. We're dealing with that. That is also telling us about stretching, reflecting, and compressing. But what's different? What are we stretching, compressing, and reflecting instead of the Y values? The X values, yes. So if that, it should say if C is negative. Guys, change this to a C right there. And if C is greater than 1, and if C, make those C's for me, okay? So if C is negative, you're going to reflect, but this time over the y-axis. Okay, the next two are weird. If C is bigger than 1, it is a horizontal something, but it's the opposite of what it seems like it should be. Think about it when we do shifting. If you have, you don't have to write this down, in parentheses, if you have like x minus 3, do you guys know that that's shift to the right 3? Okay, it says minus, but we're going to go to the right. So when you have a coefficient on that part, it looks like we should multiply by 2, like it should be a horizontal stretch by 2. It's the opposite of what it seems like. It's actually a compression, like you're cutting the x values in half. We'll do examples when we graph, but realize anything inside with that x, it's the opposite of what it seems like it should be. So when C is bigger than 1, that's actually a horizontal compression. So what do you think is going to happen when C is between 0 and 1? If C is like 1/3, it's a stretch, yeah, horizontal stretch. So C is not as simple as A. A, you can just multiply the y values by whatever that number is and you're done. For C, I'm just going to say, like, we're dealing with x values. We might be doing different things to our x values, but just know that that C is going to impact the x values, okay? All right, the H and the K are actually easier. The H is the horizontal movement that we have going on there. So the way I have it written, I've got x minus h. So if h is positive, like x minus 3, which way would we go? To the right, okay? So you can draw an arrow, you can say shift right, whatever you want to say there. But do you see how the setup is x minus h? So if h is a positive 3, yeah, I know, it's tricky. You know what you're doing when you see it on the graph. That's what matters. So what about if h is negative? Which way are we going to go? Yeah, exactly. So the horizontal stuff is always the trickier part. It's weird, not exactly what it looks like it should be. But the vertical stuff is easy. That K outside is the vertical movement, and it's exactly what it seems like it should be. If K is positive, it'll say like +2. Where are we going? It's the vertical movement. Yeah, so up. Okay. It's the, go back up there. Do you see how K is the number like outside at the end? That's your vertical translation. So it's either up or down. And it just is what it looks like. +2 means up 2. -5 means down 5. Okay? So if it's positive, we shift up. And if it's negative, we shift down. Okay? All right, let's try to actually graph something so you can see how this works. Anybody need more time on this slide? Okay, all right. Okay. We're going to graph both exponential and log functions. Looking at the first one, y equals 2 to the x plus 3 plus 2. Do you guys see how that's an exponential function? Right? There's no log written in that equation. So we're going to start with this first step for exponentials. We're going to plot the points 0, 1, and 1b. So what's the base in this first equation? Yeah. So I'm going to plot the points 0, 1, and 1, 2. And this, if you guys have multicolored pens or pencils, now would be a great time to use those. I do have extra like colored pencils up here if anybody needs them. But I'm going to plot those 2 points in red. Those are my parent graph points. Then we got to figure out where we are shifting this graph.
How would you have the point 0, 1? Like when x is 0, because if x is 0, wouldn't it be like 10? Like 0, 10?
Okay, so those are your parent graph points. Then we're going to shift them. So where are we going to go? Instead of right, if you had to guess again, what would we say? Left, okay. So we're going to go left 3 and, yes, left 3 and up 2. Okay, if you need to do that in 2 steps, like and plot points each time, that's fine. I'm going to just count each of my 2 little red dots here. I'm going to go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So those are my 2 new dots. I counted. I took this guy and I went 1, 2, 3, 1, 2. And then I did this one. 1, 2, 3, 1, 2.
Wait. Oh, from both ones?
Yep, the 2 red dots. I just took them left 3 and up 2. Right. Yeah, they're not real. They're just our starting point. Yes.
Those are the color vertex, like minus 250, second vertex, then you have to go 1 up, then 1 right and 1 2.
So exponentials don't really have a vertex. They're just this continuous, like this shape. It's not like a parabola that has.
Wait, why are we doing like left 3?
Because do you see the +3 up here with the
Yes,
x?
so we put it minus 3.
Left. It's the opposite. Remember, horizontal is always the opposite of what it's. Yeah. Okay, back to your question.
As I read the algebra too, that like in this question we would take minus 3 and 6 as a point, then we move it 1 to the 1 up, then 1
Like
right.
over and up. Yeah. Yeah. Those 2 points.
That is what we do.
Those 2 points are there. Yeah, I'm just taking the parent graph for every single one and doing the shifting. You just thought through the shift of -3 and then from there.
Is that okay?
That's okay. As long as you get the right graph at the end. Okay. All right, let's think about our horizontal asymptote. It was at y equals 0. If we shift a horizontal asymptote left or right, does that do anything to it? I'm here and I went left. Isn't it still the same asymptote? Yeah. What about if I move up or down? Okay, so where is my horizontal asymptote for this one now? 2, yes. Horizontal, like, why did I know that? It is going to be your vertical shift. Okay? All right, so y equals 2. I have the horizontal asymptote. I can now draw the shape. So guys, those red dots were just there to guide you. The green is the answer, okay? Not looking for perfection with 17 points plotted. I need 2 points that you moved correctly. And the asymptote, obviously. Okay? Questions? Okay, let's fill in domain range and asymptote. We kind of already wrote the asymptote.
Oh, so it's a horizontal asymptote, it's not a vertical asymptote.
Right. If there's a shift, it can move. A vertical shift will impact it. Yeah. All right. Domain is still negative infinity to infinity. It's always going to be that for your exponentials. Okay. Our range has changed though. What is our range? Yep. Good. Okay. Let's try the log one. No. You're going to make more work than you need to. Nope. You don't really have to know anything about logs to be able to graph this. Okay. The second graph, guys, that is a log graph. Hopefully you can tell that says log in the middle of it. Do you see up here the second dot? How it says with logarithms, plot the points 1, 0, and b1. Okay, that's what I'm starting with. I'm starting with 1, 0, and then what's the base? 2, yeah. You are so good at this, yes. All right, so 1, 0, 2, 1. I'm not going to draw it yet, but what kind of asymptote does this have? Vertical at 0, okay? Right? Logs always have a vertical asymptote. Like this would be the general shape of the parent graph. Yeah, okay? But we're going to do things to that parent graph. We're going to move it. Okay, where are we moving? Three, which way? Up. Isn't the 3 outside of the parentheses?
Are we moving it 1 to the right?
Yeah.
And then 3 up?
Yes. 1 to the right and up 3. Inside with the X is the horizontal. Outside is the vertical. Okay, we're not worrying about the asymptote right now. Nope. Just where are we shifting this graph? Do we see it? Does it make sense why it's right 1, up 3? We got that? Okay, so I'm just going to count with my points. Right, 1, 1, 2, 3. 1, 1, 2, 3. Okay, let's think this time. I have a vertical asymptote. Up 3, does that change where my vertical asymptote is? No, but going to the right, it's in a different spot, right? Where is my vertical asymptote? No, okay. Which of these went horizontally? The 1, yeah. Okay, so it's at x equals 1. Okay. Here is a vertical asymptote, right? Pretend that's an asymptote. If I move that upward, I did not separate them enough.
So in this case,
Like think about moving that line up or down. Does that change the location of the asymptote? But if I move it right or left, it definitely changes it, right? It's not to the right 3.
it's the thing in the parentheses, whereas for the other thing.
The 3 is up. It's to the right one. In the parentheses is always the horizontal shift, which impacts your asymptote this time. Ooh, I need we see it now, though? So your asymptote is at 1. And then you can draw your shape. Again, those red dots were just there to help guide you. They're not a part of your answer. Okay, what's the domain of this one?
1, 2,
Yes, so parenthesis, 1 to infinity, parenthesis. What about the range? Yes, that will always be the range of your log graphs. Okay. Domain can change, but the range will always be that. Okay, let's look at a couple that have different transformations going on. Your initial 2 points are still the same. For exponentials, they have one set of initial points. Logs have it, yes, but every single time, yes. So for exponentials, remember it was 0, 1, and 1 comma base. So I'm going to start 0, 1. What is the base? It is 2, yes. The 3 is that A value. It's your leading coefficient. 2 is the base. So I'll plot those. Just visualize it in your head like, okay, horizontal asymptote, like I know the shape of this graph. We're not going to draw that in yet. We have to deal with a couple of transformations that are different than we have been dealing with. Okay, the 3 out in front, what is that doing? That's the A. Yep. What do I multiply? Y values, right? Yeah, it's a vertical stretch by 3, which means multiply the Y values by 3. And when I'm talking Y values, of those 2 little points that I have, right? Those each have a Y value. So when I multiply, guys, I'm going to rewrite the points over here just so it's easier to see. 0, 1, 1, 2. When I multiply the Y values by 3, 0, 1 is going to become 0, 3. Hey guys, I'm hearing a lot of side conversations that are not going to help you figure this out, okay? 1, 2, what's that one going to become? 1, 6. Okay. Right? We'll deal with the negative here in a second, but one step at a time. We have more things. So yeah, let's just wait until we get to all the things. You can if you want to, if it helps you, but you don't have to. The other thing we have is the negative in front of that x. What does a negative in front of the x tell us? Yes, reflect over the y-axis. Okay? A negative 3, like where the 3 was, that would have been a reflection over the x-axis. This is up in your exponent with the x. So you're going to reflect over the y-axis. So let's think about what that means for your points. Just visualize with me. If I have the point 2, 0, and I'm going to flip that over the y-axis, where does that end up? Right. So what changed sign? The x. So you need to change sign on the x. So we're at the green points. We're at 0, 3. Can I change the sign of 0? No. So it is still 0, 3. What about the point 1, 6? What's that going to become? Okay. Let's plot those. These are our final points on our graph. 0, 3 and negative 1, 6. Okay, let's get our asymptote in there so we can draw this a little better. It was at y equals 0. Did any of these transformations actually change where the horizontal asymptote is? No, the only thing that changes it is a vertical shift. We didn't have one of those. Okay, we had a stretch, but we didn't have a shift. So your horizontal asymptote is still at y equals 0. Draw that in. Now remember, initially your graph would have gone this way where it's growing on the right side, but we flipped it, and you can see from your points it's now going to be decreasing. It's going the opposite direction. So we're going here. Let's pause for a sec. What questions do you have? There was no shifting, right? There was no like move it left 3 or up 2 or anything like that. All we did was multiply. We had a vertical stretch, and then we had a reflection across the y-axis. Does that make sense? Okay. Okay, let's do it again. Oh yeah, you guys do domain and range real quick. All right, did you do domain and range, guys? Yes. And what was our range this time? Perfect. Okay. We're getting there. Don't let them overwhelm you. Just do one piece at a time. Work your way through your graph, okay? All right, it's a log graph this time. So remember our points are 1, 0, and base 1, which in this case is 3, 1. Yes. Can we get it on the initial points? If you don't know what I'm doing with the starting points, this is not going to go well, okay? Do we see it? Okay, plot those 1, 0, 3, 1. I actually only have one transformation happening this time. Okay, it is inside with the x. Is it impacting our x values or our y values? X values, yes. Okay. It looks like 1/2 times the x value, right? Remember, in the parentheses is the opposite of what it seems like it should be doing. So instead of multiplying by 1/2, what do you think I'm actually going to do? Divide by a half, which is the same as multiply by 2. No negatives. No negatives. Dividing by a half means multiply by 2. So when you see a half in there, you're actually doubling the x values. Okay? It's not what it looks like it should be. It's essentially the reciprocal of what's in there. So Carly, if you saw like 3x in parentheses, that would mean divide x values by 3. If you saw 2/3 x, you'd want to multiply x values by 3/2. It's the reciprocal, yeah. If it was a 4x, what would we do? Yes. Okay. Or multiply by 1/4. Absolutely. Yeah, that's also what's hard is there's multiple ways to say it and you're saying the same thing. So, yes. Like the first one, divide by 3, that's the same as multiply by 1/3. Okay. All right, so on this one, we are multiplying x values by 2. So I'm going to just label under the ones I wrote. 1, 0, what is that point going to become? 2, 0. 3, 1 will become 6, 1. So 2, 0, 6, 1. So that's a horizontal stretch. The x values, yes. Yep. Okay, vertical asymptote. It was at 0, multiplied by 2. Does that change anything? It's still at 0. The only thing that changes a vertical asymptote is if you actually shift left or right. Okay, there's no shift, so your asymptote is still at x equals 0. So then you can draw maybe your shape. What's our domain? Yep. Sorry, guys, I'm just setting another timer. And what about the range? Always with our logs? If there's not a horizontal shift, like a right to left something, like not a stretch, but an actual shift, like plus something in the parentheses, there's no change in your asymptote. It got stretched, right? It multiplied by something, but I didn't actually add anything. Does that make sense? Do you see the difference? You can think about it, so the vertical asymptote is at 0. If I multiply that by 2, still at 0, right? Okay. All right, let's try some. I'm going to go not in the order that they're listed for you guys here. Let's do, wow, my grid looks weird. Do this one first for me. We're going to jump around a little and just go one at a time, okay? Try that one first. What? 1, 0 and base 1. All right, guys, so try that one. Log, get your 2 points that you're starting with. See if you can do it. Always, yes. Good job. What should we do next? Let's look. Do you guys want to stick with logs since we're on logs? rather than shifting your brain back and forth. Do that one second if you finish the first one, okay?
Yes.
So see on this one how we compare this plus even if I lose that's what shows the estimates. There's no add.
Oh, it's like
Correct one is multiplied. This is a 0. If I multiply 0, okay, so that's why that's
How do you get that?
we have a negative.
Always going down. Oh, how do we? How like I get the range is negative to
okay.
but how do you get this to be negative so it's close to negative? Because you can't go anywhere negative.
So your x values, it's going to get closer to this because you're at like 110. 1 x is negative 1,000. You actually do that.
So, but what if you get 0 to infinity? Because like you can't go all the way. Like if
That's the 1 to infinity, sorry, yeah. Okay, so we shifted here. So like as you get closer and closer to 1, so like 1.000001. That's going to be a negative number. No.
I don't know where my I thought you were
That's right.
Like over x-axis then.
Like over x-axis to multiply by the x-intercept. Okay, let's think about it. If I'm okay, so I have a point up here and it's coming down to what change sign do you have to do? One. The negative in the x or the or just multiply your y values by that number. So think if your y goes positive, okay, there's a A is negative 1, right? There's a negative 1 out of yeah. For the reflective, yeah. And then where are we at? Easier stuff, right?
Yeah, that's what you know.
It got you both, right? So instead of going like this,
Okay, that
yeah, like being able to like All right, guys. Let me go through up here. We'll see how we're doing. Mm-hmm. So I've got 1, 0, and 2, 1. Is everyone good with the starting points? Okay. 1, 0, 2, 1. Where am I going? I just have shifting on this one. Up 3. Okay. So I count 1, 2, 3. 1. I can almost see my lines. Where does that put the vertical asymptote? 1, yes, because that's where we shifted. And then we can draw roughly our shape there. So your domain should have been 1 to infinity, range negative infinity to infinity. Yes? We're pretty good when it's just shifting, right? Like we do that pretty well? Okay. Anybody questions on that first one? Okay, let's do another log 1. All right, so my initial 2 points will be, I'll squeeze them in over here this time. 1, 0, and 4, 1. Everybody okay with that? Okay. 1, 0, 4, 1. All right. Order of operations matter here when you do your transformations. Think about order of operations. Would you multiply first or would you add or subtract first? I would multiply, right? So I need to deal with that negative out in front and multiply my y values by a negative or flip, whatever you're going to do with it. You have to do that before you do your shifting. Otherwise, especially with the vertical shift, your graph will just not look right. Okay? So negative out in front means the point 1, 0 will not change. 4, 1 will become 4, negative 1. That's your first step. You're probably off. Your shape looked okay, but where your vertical points were was probably wrong. Okay, then I can do the shifting. So where am I going? Right 2 and up 1. So 2 ways you can do that. You can plot the green points and then count over to the purple. Or you can just add 2 to your x values and add 1 to your y value to get your new points. That's fine too, like whatever works for you. We're going to end up at 3, 1 and 6, 0. Do you guys want to see the progression of the green to the purple? Like, will that help you, or are you okay with how I got there? All right, let me sketch in the vertical asymptote. Where is the vertical asymptote? X equals 2. Good. Okay, I think the hardest part with these, when you start flipping things around, is understanding the shape. Okay, I saw some go like, well, I'm just connecting these, and then you kind of ran into your asymptote. It doesn't work that direction. You flipped it, so it is now going this way. All right, let's stop on that one for a minute. It's definitely trickier when we're flipping.
Wait, so if it's a negative log, that's
It's flipping over the x-axis, yeah. Yep. All right, domain. Are we okay with 2 to infinity? And range, as always, negative infinity to infinity. Troubles anywhere? It's just a lot of little pieces to put together, but just do it one at a time. I'm not expecting you at all to just look at the equation and like draw the final graph. That's no, like go through your steps. Okay, next one I want you to try is that last log one there. We'll just stick with the logs. We'll do all of those in a row so you've got your points.
Yeah, the base was 6.
No, what is the base? 3.
So you would have multiplied like.
That's one of your transformations, but it doesn't change what the base is, okay? All right, guys, try that third one for me.
What about the negative next to that?
Yes, okay, actually, let me help you with one step on this, guys, because that is definitely different. I'm going to write it down below because there's not a lot of room up there. Okay. We need to deal with that negative with the x, and we have to factor it out. Yeah, so there's a negative there. X minus 2 inside, and then the minus 3 is still out there. We have to, sorry guys, that's really low. We have to look at it this way so you can separate out what's happening. What is this negative out here in front of the x doing? Reflected over y-axis. Your x changes sign. So think if your x goes from positive to negative.
Now our x is changing signs.
Yes, right? Because the negative's by the x.
So we're not dividing or multiplying that. The negative.
I mean, there's no other number here. So you're multiplying by a negative 1. No, inverted, it's still negative 1. Okay. And then which way are we actually shifting in here now? To the right. Okay? Think about order first. You're going to deal with this guy and this one before you deal with these two. I'm going to give you a minute, okay? This one's going to take some time. Is this inside? No, so what does it do? What? Out in front, multiply the y values by that.
Wait, where should we start?
This and this. You could actually do these together if you wanted.
Negating the y value, x value, and then multiplying the y values by 2.
Yeah, you can do that all at once. And then you do this.
So if there was a number outside do we do that with our
Like in here, you can do
Yeah.
Yeah.
So here we multiply and then outside of that. Oh wait, always the y value.
Yeah, leading coefficients, those impact the y value.
Do we do a little bit here reflecting this was all like that this is all
Do this first. Yes. Then you shift. Okay. Multiply before you add or subtract. Keep talking to each other, work together. You can do it.
Not too good. Well, last year test was like I think it's like well, I wasn't like
Hold on. There's only one of me.
So is it a positive? Is our asymptote a positive?
Your graph is now on the
Oh, she got pissed about the question.
You want to sit next to me?
Try it. I'm like, I did. That's
It's
not
all by factoring out the negative and then the next.
Did you try it first? Oh, yeah. Okay.
Did you find
I'm
the
sorry. No, I only listened to fucking on your. No. The room was quiet. I could hear. No, I was guessing the question, but I didn't try it. You sound stupid. That's how you sound. Because you're really no, it's just that I want. I'm sticking to your phone. Come here. If you have such a problem. Oh, yeah. So the time.
All right, guys, let's look.
How did you get negative?
Okay, guys, we start with 1031. Everybody with me? Yeah, okay. Guys, close your laptops. You don't need them right now. Thank you. Okay, we have to deal with the 2 out in front and the negative before we do any shifting. What does the 2 out in front do? Multiply the y values by 2. So what is 0 times 2? Okay. What is 1 times 2? All right. In that same step, we can deal with this negative. What is this negative right here doing? Yes, changing the sign on your x values. So 1 becomes -1. 3 becomes -3. I guess I should have plotted my initial points too. Okay, Then we can do our final shifting. We have to go right 2, and we have to go down 3. So if I'm at -1 and I go right 2, where do I end up? 1. If I'm at 0 and I go down 3,
-3.
yes, so 1, -3 is one of your points.
Wait, 1?
Yes.
Okay,
Yeah, okay. Then -3. If I shift to the right 2, where do I end up? -1. Yeah, I'm at 2. I go down 3. That is -1.
Wait, why?
What? Sorry.
How did you go from -1 to 0 to 1 2?
Okay. I don't know if you can even see down here. The right 2 and down 3, the shifting.
Oh, so we do that for both?
Yep. So like right 2, that's impacting the x values. Down 3. Right 2, down 3. I just like added 2 and subtracted 3 from the x and the y.
Oh, and then sorry.
That's okay.
From the red to the green.
Yep.
I put 2.
So there's a 2 out in front, which is a vertical stretch by 2. So I multiply the y values by 2. 1 times 2 is 2.
Oh, so we only multiply the y values?
Mm-hmm. And the x values, I changed the sign. I multiplied by a -1.
Because it's negative.
Yes. It's just so many pieces. Where is the vertical asymptote on this one? Yeah, x equals 2. So drawing your graph, realize it's been flipped, like it's on the other side of your asymptote this time. So it looks like that. So the range, always -infinity to infinity, but what's the domain this time? Yeah, -infinity to 2. Guys, that is like as tricky of a log graph as I would give you at any point, okay?
So that's like trickier than you would normally think of?
I would give you one up to that level of trickiness. I won't give you one harder than that, okay? Questions on graphing logs? Okay, let's practice the exponential ones again. All right. So we're now going in order on the exponential ones. Do this one first. Oh, sure. No, she just asked to see. Uh-huh. Yes. That's the A value, yeah.
Why? So it has to be inside parentheses. So that 2 on the x on the x value.
Are you good, Reem? Okay. All right, guys, start your exponential. Remember your points now that you begin with are 0, 1, and 1 base, which in this case is 2. Deal with the 2 out in front before you shift. Yeah, there's a lot of 2's. The 2 in parentheses is the base.
Oh, yeah. multiply. It doesn't really matter, but just have a 2 in the first step.
Yes. I really should not have put so many twos in that problem.
And the fours. Yeah. And then you go left 2. And then down 4. And then 1, 4. You go 1, 2, 1, 2, 4.
How is she still
Like, and then like 1, 2, 1, 2, 3,
But what? How is she?
Minus 4 4 minus 0.
So
You're shifting. You do the
you're
shift.
shifting 1, 2 back, 1, 2, 3, 4.
Oh, you did.
1, 2,
So that's what that point is 2.
oh, I lost. And the last like points we get is what we grab.
Mm-hmm. You can graph the others along the way, like if it helps you see things. Sometimes I just get like lost in the dots, though, and I'm like, I'd like to just have the final ones. Okay, guys, I did number 4 up here. If you're good, move on, try number 5. But take a second and let me know what questions you have. Remember, you have to do that vertical stretch before you shift. Multiply before you add or subtract. Oh, okay, yeah. No, you are multiplying the x values by something. It says 1/3, so you do 3. Yeah.
The one that stretches.
I'm still thinking does that say -2, -2?
It does. It does. What did you want it to say? So this 2, right? That turned the 1 into a 2 and the 2 into a 4. That gave me green.
Yes.
Okay. Then I need to go left 2 and down 4. So left 2, that means -2. So down 4 means -4. Yeah, you see it? And then same thing here. Left 2 correct.
What?
The base is 2. 1/3 is part of the exponent.
The mean is -3. Green is yeah, that's like this one is really
the x value.
That was not straight level. That's a squiggle. That was a goal.
We're squiggling.
For this one, factor out the 2 first.
Yes, good. Why did what?
Why did Adele cross the road?
I don't know.
To say hello from the other side.
I like it. I like a good cheesy joke, so I appreciate it.
I don't know why I copied you in this one.
Somebody have a hairball? What is happening? All right, guys. I've labeled it number 5. This one with the 1/3 x. That's impacting your x values. What are we actually multiplying them by? 3. Yes. Okay. Then you do your vertical shift. We have to go down 3 from there. So your points should be 0, -2, and 3, -1. X values. Because do you see how it's with the x? Okay. All right, guys. Domain, as always, -infinity to infinity. Your range this time, -3 to infinity. Questions on that one? Yeah. Correct. Yep. Well, hold on. I want to say something about the last one before we get to the graphing of that. Any questions on this one? Are we getting it? Walking around, it looks like we're getting there. We need some practice, but we're getting there. The last one, what do you notice that might be kind of special?
Like, when we take the 2 out of...
Yes. Guys, remember on this one how... Hey, everybody up here. How I had to factor the negative out of this one because it was inside with the x? What do you think I need to factor out on the one over there? The 2. So I'm going to write it down here for you.
Change the -2 to -4.
Yes. Change it to that. Guys, this is what you're actually graphing. You can even rewrite it if you want. Instead of -2, write it -1 times 2, if that's easier for you. Rahul, you got the graph done?
So now does this 2 still affect the x? Or now it affects the y?
The x. It's with the x still.
Can the 2 be powered by 2?
Can 2 be powered by 2? 2 to the 2? Yeah.
So we just and it becomes 4 powered by x -2 plus.
So your shifting has changed. You're going right 2 instead of right 4 is what it initially looked like. But you're getting horizontally compressed. Okay.
Sorry, I know I have my glasses on. Okay, it says y equals what?
Oh, I did -1 times 2, if that's easier for you to think about than just -2. Yes. Yeah.
Wait, the only thing to take is that it only affects to the right, right? It shouldn't affect anything else.
Wait, what? Okay, what? No, the base is always positive. That's why I rewrote it -1 times 2. Okay.
The only thing by taking out that 2 only affects how much going to the right. Everything else is going to the same.
Yeah, you did the horizontal compression. You multiplied your x values by 1/2.
I multiplied my x values by 2. And
Nope, not by 2.
By negative.
No. Thank you, Ben. You two talk. Yeah. Well, order of operations.
Wait, what? You're confusing me.
That's so much effort.
What?
We wanted to just if you're like testing.
It's also does it look like I have to figure it out?
No, the one actually is so much better. You know what else?
You're almost done. No, I gotta finish.
Wait, why? Negative.
I'm actually lost. I absolutely hate this question.
It's a tough one. All right, the negative out in front. That is changing your y values. The 2 up in your exponent, that's impacting your x values. You're multiplying by 1/2. 0 times 1/2 is still 0. That is a lovely 1/2. Because there's a negative out in front. The y values. Yes? Then we have to go right 2 and up 3. 2, 2, 2.5, 1, 2. I did not take it. All right, your your horizontal asymptote is at 3. It got reflected over, so it's now that way. I know we're running out of time. Where'd I get what? So this 2 doesn't mean multiply the x values by 2. It means multiply them by 1/2. So 1 times 1/2, that's where I got the half. Because the negative outcomes. Guys, this one is very challenging, okay? We'll do more next time. There is Delta Math. I haven't posted it yet. I will do that in just a moment. Negative infinity to 3. Yeah? Okay.